Hello, my Calc 2 students. Today we start new section, new chapter. It's chapter 9, and today we talk about 9.1 sequence. How we define sequence? Sequence is defined as a function whose domain is set of positive integer. And this situation you have f from 1, it will be first term your sequence. F from 2, it will be second your term in sequence, and consider f from some n is a n. And because positive integer is infinity set, this means your sequence has infinity elements. Okay, doing some examples. Let's go. Our sequence gives us this formula is n over 2n minus 1. This means first term will be 1, 2 minus 1. It will be 1. Second term will be 2, 4 minus 1 is 2. 2/3 I want to write, and write is 3, sorry. 2/3. Okay. Third one, it will be 3. 6 minus 1, this will be 3/5, and continue. You can count any element when you want. But sometimes, example 2, you have for sequence, you have this kind of formula. For example, first element is 5, and any next element you can count, use element before. This means n plus 1s, it's n minus 2. What does mean? We can count them. A second bill will be a first minus 2. This means 5 minus 2. It will be 3. A third, it will be a second. This means 3 minus 2. It will be 1. A fourth will be 1 minus 2. It will be negative 1, and you can continue counting all elements. When you have sequence, question about limit of the sequence. And now we have definition. Limit our sequence an n approach to infinity equal L. It means if for any positive epsilon exists number n, practically depend epsilon. For different epsilon you have different n, and for any n greater than n, absolute value an minus L, let's be less than epsilon. For limit we have some properties. If you have two sequence, one is limit an is L, and second sequence limit bn equal k, for example. Then you have first limit sum or differ to sequence equal sum or differ this limit. Second, if you multiply your sequence for constant, and try found limit, this means you multiplied for same constant your old limit. Third one, if you multiplied to sequence and try found limit, it will be product your limit. limit product is product limit. And fourth one, limit an over bn will be L over K if K non-zero and bn's non-zero. And now we have a couple of theorem and definition about our sequence, how we work with sequence. First, this will be squeeze theorem. Squeeze theorem. We have if limit two sequences equal and for sequence you have this kind of inequality. This means sequence Cn stay between An and Bn for any n greater than for some numbers. Then limit our third sequence, our sequence between, it's same like limit A and B. Have one more theorem, absolute value theorem. Tell us for sequence An if limit absolute value An equals 0, then mean limit An is equal 0 to. Now we have a couple of definitions. One is definition monotonic. Monotonic sequence. First, if your sequence A1 less or equal A2 less or equal A3 and it's work for any elements, then this sequence we call non-decreasing. Second one, if A first greatest or equal A second, who is greatest than equal A third, and then this sequence we call non-increasing. Oh, sorry. Non-increasing. One more definition. Definition bounded sequence. Our sequence an, first definition, is bounded above if exists real number m such as an less or equal m for any n. Our sequence is bounded below if exists real number n such as n less than an for any numbers n. And third one, our sequence is bounded if the sequence bounded above and below. This means an stay between n and m for any numbers. And now we have very important theorem. If our sequence is bounded and monotonic, then it converges. Looking here, this is be carefully. This theorem works only one direction. This means bounded and monotonic converges. Converges is not mean is bounded and monotonic same time. It's mean bounded, we can prove this fact, but it's not mean is monotonic. Okay, great. Before we start solving some example, I'm remember you this fact. N factorial, it's mean you multiplied 1, 2, 3, and all positive integer until n included. This means if I need counted 5 factorial, I need multiplied 1, 2, 3, 4, 5, and this will be 120. Okay, this means you can count in any kind of factorial. Okay, and now solving couple of examples. Number 20, here is only simplifying. This is ask us only simplifying this writing. Here you have 2n plus 2 factorial over 2n factorial. Oh, we can remember definition. This means your numerical is 1 times 2 and continue. Then I write 2n, then what has come to n? Because we have in the denominator, I'm trying to simplify. What is will be next number? It will be 2n plus 1. And last number is 2n plus 2. What you know about our denominators is 1, 2, 3, and continue until 2n. If we cancel it, this cancels all of this, and this means you have 2n plus 1 times 2n plus 2. We can one more example. It's not from book, but for one I try evaluate. For example, I have 6 factorial divided by 4 factorial. What I know here? All is until 4, it will be similar, but now we have next number after 4 is 5, and then last number is 6. This means here we have 30. Okay. This is only a little bit, remember you how work with factorial. Now try solving some example. Example number 26. You need found limit your sequence if your sequence is an equal 6 plus 2 over n squared. This means I need found limit an and approach to infinity. It will be limit 6 plus 2 over n squared and approach to infinity. But we have 2 over infinities will be 0, and then you have 6 plus 0, or you have 6. It will be your answer. One more. Oh, I'm sorry, it's not 26, it's 20. 22nd. 22nd question was this. 24. You have your sequence now is an over cosine 2 over n. Okay. Try solving. We have limit an and approach to infinity. It will be limit cosine 2 over n and approach to infinity equal. Because cosine is continuous function, this means we can switch limit and cosine, and we have cosine from limit 2 over n and approach to infinity. 2 over infinities will be 0. This means here you have cosine 0, and you know it's 1. Here we how we count it. Okay. Number 38. 38. Here your sequence is an equal n minus 2 factorial over n factorial. We can simplify it now, or you can simplify it. Okay, simplify it now. What we have here? Looking for lower number. Lower number, it will be n minus 2. This means here we have n minus 2 factorial. N factorial is n minus 2 factorial times next number. It will be n minus 1. And next number, it will be n. You see? This means here we can cancel it, this part and this part. And our sequence is 1 over n minus 1 times n. Found limit this sequence is no problem. Limit an and approach to infinity. It's mean found limit 1 over n minus 1 n and approach to infinity. And this is exactly will be 0. Okay. Again, one more interesting example in example number 40. Okay. Here our sequence is an and sine 1 over n. Limit 1 over n and approach to infinity. Here I will write like limit sine 1 over n, 1 over n, n approach to infinity. If n approach to infinity, 1 over n approach to 0. You can do it, or you can write now, or you can do it one more step. Limit x approach to 0, sine x over x, whereas x equal 1 over n. What this limit is? This limit is 1. This means limit is our sequence is 1. Okay? I think it's last question about limit is number 44. We have sequence an equal cosine pi n over n squared. What is interesting in this example? Because if you look in cosine pi n equal, it will be equal 1 if n is even number. This means we can write like 2k. Or equal negative 1 if n is odd number, 2k plus 1. But is it exactly work like negative 1 is the n power? Because if n even number, negative 1 even power, it will be 1, and negative 1 odd number, it will be negative 1. This means our sequence an equal cosine pi n over n squared. We can rewrite like negative 1 power n over n squared. Okay? And what will be limit an? It will be limit negative 1 power n squared and approach to infinity, and any situation it will be 0. See? Okay, great. And two question 46 and 52 we're solving. 46, you have sequence 1 half, 1 over 6, 1 over 24, 1 over 120, and continue. How you can rewrite formula for this sequence? I think we can. This is 1 over 1. Here is 1 over 1 times 2. 1 times 1, 2, 3. I think we can see what is it. This means an is 1 over n factorial. 4 factorial gives us 24. 5 factorial gives us 120. This means it's work. We found our formulas. And last one, 52. Here we have this kind of sequence. 1 over 2 times 3. Second term 2 over 3 times 4. 3 times over 4 times fifths. 4 over 5 times 6. Okay. If you're looking for numerical, is 1, 2, 3, 4. This means looks like numerical is n. If you're looking for denominator, is one number 1 greatest than you have in the numerical, and second number is 2 greatest. N plus 1, n plus 2. This means we found formula for our sequence. Okay, do your homework and we continue our work.